Good morning, everyone. I think we have our meeting room worked out. Yay. Yes, I am on camera. I do own one, but it's kind of a little bit broken, I guess. So it usually works. You can see the nice 1970s office motif I have going here. All right, I suppose we will get this meeting started here. I think some of the guys are still in the core stand up, but they'll probably trickle in. So what's going on this week? Sage decided to dig in and rip part of the fast dispatch code apart, and I don't. From talking with him, I don't think we were able to rip out quite as much as we wanted to in all cases, but he was able to get a lot of code out of the kind of normal path when you are on when you're not on an existing, you're not dealing with an existing cluster. So that's the good news. I have not tested it yet, but it sounds like maybe it's starting to pass tests. So very good news. Hopefully we will see some gains there. Previously, Dan Lambright had attempted to kind of remove a lot of the locking there, and unfortunately wasn't actually seeing any gains. We were seeing actually in some cases a little bit of a regression. So hopefully Sage's attempt will do better, but we'll see. Also, there's a really exciting PR here. Actually, I put Sage's Igor's. From Igor in Blue Store. He is working on reducing the memory usage for blobs in BlueStore when doing appends and overwrites. And I confess, I asked him to send me a link to the code so I could look at it, but I haven't done so yet. But the thought here is that we're reducing ONode memory usage from about 280K per ONode to 32K. So if this works like I think Igor's hoping it will work, it's a pretty dramatic reduction in memory usage for ONodes, which would be fantastic. Let's see, nothing really of major import flows this week. There was something that Sage was working on here, but after talking to Helmai, I think he likes Helmai's approach better, so that one is just getting closed without being committed. Yeah, and there wasn't a whole lot else going on. Just a little bit of movement on this ARM CRC32C implementation, but it still needs QA. So that's kind of it. Not a whole lot of stuff going on, but maybe a lot of things going on behind the scenes. So I think we already talked a little bit about Igor's patch, and Sage is looking into Nick Fisk's sync write performance issue that he found. I think he was, the last I talked to him, he was dealing with random hardware issues on his test setup. I think he got those resolved though, so hopefully if he didn't have time to look at it earlier this week, he'll be able to look at it later this week. And then I've been actually doing quite a bit of RGW testing and running into some interesting kinds of things going on. I do have some results, but I think maybe I'll leave those for next week since right now I'm running into issues where different clients, when there's really high concurrency against one RGW instance, I'm running into issues where certain client processes are stalling or starting really late compared to other ones, even with really high RGW thread counts, and also with higher throttles for the objector in-flight ops and in-flight op byte limits. So I think it's going to actually take some debugging to figure out what's going on here. But anyway, that's getting into the weeds. So hopefully next week I can present something useful. But I guess maybe the gist of it so far is that things look pretty good with replication, but with erasure coding for the data pool, I'm seeing kind of scaling limitations, or not scaling limitations, that's not right. We seem to be more bound by latency than we would than I think I would expect. And then we are in the replication case. And then once we try to increase concurrency, there are all these other weird problems showing up. So anyway, that's what I'm digging through. That's all I have. It looks like a couple of people have added things in here for this week that they want to talk about. So maybe start with Jamie here. Write performance with Kraken on hard disk drives.
Where are you looking?
Under BlueStore, there was one added here for cloud.proinnovation.es.
15.
Is anyone here that can talk about those?
What currently looks like.
Okay, well, let's move on. Nick, I see you've got some snap trim throttle results here.
Yeah, so this is from the work Sam was doing to add a throttle to snap trimming. So if I just share the screen. So are you seeing the presentation?
I'm seeing your screen, your desktop.
Ah.
Along with a health warning.
Okay, so that's on the other window. Hang on. Right. Okay. Let's try this one. How's that looking?
Excellent.
Okay, right. So just in case there's people watching wondering what this was about, I'm just going to cover sort of a very brief history. So I was seeing during the day very, very sort of high spikes of latency, and it was a bit confusing sort of what was going on. So I looked into it, and it appeared it was the snapshots when they're being trimmed after they're removed. Very big latency, literally all I/O, and the cluster just drops to zero. In some cases, I've had OSDs time out and sort of get corrupted. So this was something I was sort of causing quite a big problem, so I wanted to look a bit further into it. Now, in previous versions, you've been able to use the sleep for the snap trimming, but since dual, that's moved into the main I/O thread. So actually, that just blocks I/O as well. So you can see like the green line there was from a node where I'd set that sleep on the snap trimming, and although it stops stuff timing out, it actually sort of makes the I/O problem slightly worse. So to test out Sam's patch that he's created, I sort of managed to sort of recreate a testing scenario on my test box with 4 7K disks. I made a snap and generated about 50K of dirty objects. And then during the removal, I run a 4K random read QDF1 read test. So on sort of the current master, that's what it looks like. The I/O practically just falling to the floor during that snap removal. So Sam made this branch, and effectively it gives you a yeah, I hope you like the titles. So he made this branch, and it effectively limits it to 2 PGs per OSD, and also you get a status now in the sort of the Ceph status display, which is really handy because you can actually see sort of how far along and that process you've got. So it's better, but very, very spiky. So you know, just looking at that, there's several seconds still where I/O is pretty much on the floor again, which is a lot better than what it was, but it's still not great. So I then tried to set the throttle to 1 and also the concurrent snap trims to 1. Didn't really make a lot of difference. Maybe slightly better than 2, but not great. So then I tried sort of playing with the right back throttle, because it looked like looking at IOStat when these sort of 0 IO periods were happening, that there was just sort of like 50, 100 Q depth in all the disks as it's sort of flushing out the buffers in the kernel. So I'm guessing what's happening is these operations, even though they've been throttled to 1 or 2 at a time, is that they're getting immediately yacked by the journal, and then they're sort of building up, and then when they get flushed down to disk, it's saturating the disks, and they can't perform any reads. So I tried dropping the right back throttle from 500 and 5000 to 50 and 500, and that sort of had quite a dramatic effect of removing a lot of the sort of spikes down to zeros. There still is spikes, but it looks a bit smoother. I then tried playing with the snap trim priority and cost, but I think at this problem, it's happening below the queuing in Ceph, so it's all sort of below that level. Again with the right back throttle, yeah, and then so really I'm sort of out of ideas now. I mean, it's a massive improvement on what it was. but I think any work needs to sort of be done below the sort of the queuing or throttling in sort of the main part of Ceph is does the right back throttle with the default of starting at 500 IOs.
The supposition is that while we're only allowing CPGs to trim, it's hitting the journal and then the page cache and then being considered complete, but the work hasn't been done yet, right? So it's building up. All right. And that's why the sleep parameter worked in the past, because it artificially rate limited the number of requests to something that the disk could actually do. Okay, yes, I can do that at the OpQ level. Just introduce something that will do essentially the same thing the sleep parameter did, but without blocking the thread, and then we can give that a whirl. That's pretty unsatisfying though, because you'd be able to produce the same effect by sending the same queue depth of writes the cluster normally.
Yep.
Yes, I was just going to mention that I sort of did some very.
That's what the write back throttle was meant to fix, because it didn't.
Yeah.
I think what happened is that we tuned the write back throttle to get maximum throughput.
Yeah.
Yeah, we did.
Which means really deep queues, and that's sort of the worst case. I wonder if just for the snap trimming, instead of adding a sleep, just making a non-readable callback for completion.
It is. It's waiting for the unreadable callback, but it's only being applied to the page cache. It's not being synced.
Oh, I see.
Yeah.
Okay.
No, it's waiting for incomplete. It's not just waiting for the journal commit. It's just that for us, readable means applied to page cache, not synced.
Yeah. Got it. Okay.
So yeah, I mean, I have been doing some other brief testing with, doing this like with backfilling and other stuff, and I am sort of getting the feeling now that the right back throttle, like you say, has been tuned for getting the maximum performance, but actually, in most cases, that sort of read latency is probably more critical,
well,
and it's probably getting too far ahead.
That part was a deliberate trade-off, and that's why there's a knob. So if you wanted to play with that and report back to the performance meeting what you come up with, that would be good. But for many people, they really do want the throughput, especially if there's caching somewhere else. So it's hard to say what the default at.
I wonder if it's worth repeating this with BlueStore.
Most likely. Mm-hmm. Although we do have to fix this for FileStore too.
Yeah. But I'm curious if we do better.
I'm betting you don't have this artifact at all, actually.
Hopefully not. but yeah, it'd be nice. I mean, there is still. Oh yeah, because there's no asynchronous work
at all. There's no page cache. Yeah. By the time it's reported committed, it's all done.
Yeah.
So maybe this happened before I got in, but why do we not just set the cost of a snap high enough that it accurately
reflects the
Because that's not the problem.
The problem is that by the time that the file store considers the I/O done, almost no work has happened yet. That's fundamentally the problem.
Oh, and so we can't even block it across the sinks. Okay.
So we have to make some random guess as to how long it's going to take FileStore to actually get around to doing the work that it already finished.
Okay.
Yeah, the easy thing is probably just to do a delay, like you were saying.
What's that? The easy thing is what?
It's to sort of introduce the equivalent of a delay.
Well, we're going to do that because it's a simple short-term fix.
Exactly.
But long-term, I think BlueStore is the answer. I think this would actually work in BlueStore.
Right. Maybe Nick, if you could confirm that, that would be super helpful.
Okay.
I'm just hesitant to do anything complicated with the file store at all.
Oh no,
we're sort of fundamental. Yeah, it works. It sucks. Yep. Okay.
And it's worse. The only way you can get the files to do this for you is to f-sync the thing on the way out, and that would completely tank performance. You don't really have a choice.
Yeah. Yep.
Which, by the way, is what would happen if you turn the write back throttle low enough. it would make it so that you can't open a new file descriptor without syncing an old one.
Yeah, okay, I'll probably do some testing on both, repeating that on Blue Star, but also just out of general interest, trying to restrict the right throttle more to get less spiky sort of read performance.
And there, let's see, you're working on, this is current master. So the back off throttle allows you to set a curve if you look at the documentation.
Oh, is that the stuff
Or how it injects. What's that?
Was that the stuff Somnoff was working on? If you,
yeah, but I rewrote it.
Okay.
So, yeah.
Okay, right.
Cool. Thanks for looking at this, by the way. I know there are other people with the same problem. The original sleep solution was like really unsatisfying because while the original thing did kind of work, there was other stuff in that thread pool that did get blocked when the sleeps were happening. So it wasn't a great solution.
Yep.
All right. It looks like Nokia has some Blue Star results they would like to share. Are you guys here?
Yes. I attached the link on the path, on the meeting path. This is Jaime. Hello.
Hello.
Mark.
Yes.
Yeah, there is a link with a presentation, a PDF presentation, and the raw data and an Excel sheet with the test results. But basically, I want to present you two results. May I share?
Oh, absolutely. Yeah, absolutely. I don't see the link in the Etherpad. Were you? Did you?
It's right there.
Oh, really?
It's under purple. It's right below cloud integration.
I was looking at the yellow. I was looking for a yellow one. Okay.
Yep.
Are you able to see the presentation?
Yep.
Yeah. Well, sorry, I couldn't attend the lab last week, but you asked us to provide certain information about how we gathered the test results. We are using basically IO-stat. Okay, this presentation, this PDF is on the link on the path. So IO-stat is used for gathering all the IOPS to disk, and then all the post-processing is done with XLS. Well, some time ago, I have doubts about the different performance impact of using different protection codes. There is a code 4+1, or there is some code 3+2. Sorry, it's 3+2. And more or less, the performance is more or less similar, and impact on only write test is fluctuating over different compactations. We also make the same test on SSD disk, performance was better. So what we see from our real point of view is a fluctuating bandwidth for writes, but it's also the same effect on the reads. So in this small graph, I made some numbers. It's just for comparing what is the average bandwidth that we get on writing and the maximum guaranteed bandwidth, comparing edition code 4+1, edition code 3+1, 3+2, sorry, and edition code using SSD disk. Okay, where clearly we get more or less double bandwidth using a single SSD disk for all the RocksDB database. But well, after several considerations, that we finally made new tests with the Ceph Kraken 11.2.0 version. And we have a big stopping problem here with the memory. We ran out of memory in our test. We passed the test previously, but with this new version, we ran it out of memory. We have 5 nodes with 69 hard disk drives per node. And then we start looking into the change between the previous version and this version, and we finally found a drastic change configuration on the cache. In the previous version, the cache was around 500 megabytes, and now it's 5 gigabytes. So the problem that we had was caused by this change. There is a different configuration by default values that are using more cache. That's all. In our test, we were catching until.
Isn't Booster cache size 1?
I see. This is not the total. This is per shard, maybe.
I think it's not supposed to be.
If you multiply that by 5, you get 5 gigabytes. This is my guess, okay? I don't know why, but it's a fact. Yes, look at the different results that we are getting here. After running 14 hours of test, you can see we created 2 pools with 5 different disks, and we were using 7 gigabytes of RAM per disk with the by default settings, reducing the cache to 100 megabytes. We were using around about the same that we were using with the previous version, okay? So I mean, this is something that may be not relevant for people that are not, short on RAM, but we were. And the fact is that when we ran out of cache, the system, the kernel, start the OOM procedure and kill a process. Okay. So the complete cluster test, our test stopped because decided to kill one Ceph process. Okay. So here in this presentation, we explain the problem. So probably the cache is configured in a different way, and at least for us, by default, we were using much more.
Okay, so I just checked the code, and it is dividing that number by the shard. So it's supposed to be the total, not the per shard value. So if you're using that much, my guess is that it's a coincidence, and there's some other reason why it's using more memory than it's supposed to. There's a command called an admin socket command. You do ceph daemon osd dot whatever dump _ mempools, and that will tell you how much RAM it thinks it's using and for what.
Okay, good. Okay.
You can run that on one of these when it's in this state. That would be super helpful. There's also actually, if you can do one other thing, if you set mempool debug equals true in your ceph.conf, you can't change it online. You have to set it in the conf before the OSD starts. But if you set that to true and then run it into the state and then do dump mempools, we'll get detailed breakdown of where all that memory is being used, at least hopefully by some of the system. And that'll hopefully help us figure out what's going on. My guess is that there's actually a subtle bug in that there's a buffer probably that we're not rebuilding, and so it's effectively leaking a bunch of buffer memory. My guess is that's what's going on, but we should.
In any way, this test ran 14 hours, and with this only change on the cache, we stabilized the RAM use of the Ceph. Okay, with this only change, the only change was this, the booster cache size, reducing that from 1 gigabyte to 100. Okay, well, more doubts that we have was the current performance that we were able to get now that all the RocksDB and data is going to the same partition on the disk, okay? And the overall result is better than in the previous version, okay? if we compare our current test with our previous test where RocksDB was in a different partition, now the result is better, but we observe the same fluctuation on the writes.
Mm-hmm.
Well, that's all. But my only concern now is that by some reason, at least in the previous version of Ceph, we are observing lots of reads on the data partition on BlueStore. And when I mean a lot of reads is 2,000 reads on the BlueStore partitions. And I don't find any reason for that. And this lot of reads is where the lower write performance is achieved on the test. So I start thinking that by some reason we need to read on the BlueStore data partition while the compactation takes place, but I don't understand why at all. I don't understand why we need to read 2,000 requests per second while only writing.
Is this the case where the you didn't have a separate DB partition that BlueStore is on, or sorry, the RocksDB BlueFS is on the same partition as BlueStore?
No, this was in 11.0.2. Yeah, it wasn't not. Yeah, now we can distinguish IOPS.
Okay.
In the current test.
Is it possible
and the read IOPS? Yeah, I guess that's my question. Because usually in the past, I think in general the reads, there should be a bunch of reads coming from the RocksDB database partition. Basically, because after RocksDB does a compaction, it basically invalidates all its cached data, and then it has to like fault it all in again. So every time it compacts an SST, it then has to like read it again, which is really irritating. But all those reads should be coming from wherever RocksDB is storing its data. So it's usually the DB partition if you have one.
Yeah, I mean, in the previous version, we detected that. In the current version, we cannot distinguish which reads are caused by RocksDB or by.
I see, because they're on the same partition now.
Yeah.
I see. Okay.
Yeah.
Well, here's my suggestion is that you try BlueFS buffered IO equals true. That will basically try to use the OS page cache to cache those files that are written out during compaction, and see if that affects those read IOPS. My guess is that it will, but if you could confirm it, that would be really, really helpful.
Okay. Yes. Okay, we will try. Which command do you mention?
I put it in the chat along with the mempool. So it's BlueFS buffered IO equals true.
Okay, perfect. That's all from our side. Thanks.
Awesome. Okay. Yeah, thanks. This is super helpful. If you're able to repeat this test with the buffered IO setting and with the mempool debugging, but those two pieces of information would help us a lot. Thanks a lot.
We'll try.
Great. Thanks.
Out of curiosity, what was the test thing that you did? Was it like 1 megabyte writes that you were doing for 19 hours when you got memory kicked up that high? Okay. Just in case we need to reproduce it internally, I wanted to have some sense of what.
So 1 meg objects and I think, was it 4+2? Something like that.
3+2, I think.
Yeah. Okay.
Yeah. Cool.
Cool. Okay. That's everything, I guess, on the list. I can give a quick update on the fast dispatch stuff. I guess there's not a whole lot to report. The pull request that does all the preliminary work is basically ready to merge. The one that actually changes the fast dispatch code is the last piece. So I need to, once the other stuff is in, I'll do testing on that. But I think it's pretty close. I did go back and look at the sort of the last bit that I was worried about after all the requeuing changes was the get reserved map and release map calls. Because those used to be called heavily during fast dispatch. Now they're only used in the legacy client handling. So I'm not so concerned about that, but it turns out that they're also used every time you send a message in the OSD, it has to get a reference to a map and then release it. So regardless of fast dispatch, it's still a hot path. So I went back and looked at my original.
It does?
Yes. Yep. Oops. It's because we need to, you have all these threads that are running that are sending sending messages to other OSDs, and we need to make sure they don't send messages to OSDs that we just marked down. And so we have to flush all those out, await reserved maps or whatever, before we start marking stuff down. So I think it's still worth optimizing that, basically. So I went back and looked at Howmai's pull request, and I think it makes sense. It basically amounts to doing incrementing and decrementing an atomic in the fast path, which is pretty good. We can probably do a little bit better with RCU, but I would rather take that step first because the RCU stuff has the weird threading requirements that you register all threads and so on. So I think that's probably the next step. But just not having to take that during fast dispatch is probably pretty good. Yeah, we'll start with fast dispatch, then improve the get reserved maps release map. I think between those two things will be in much better shape, at least. I guess the only other thing I'll mention is that in going through this, doing this cleanup, I want to go back and audit all of the cases where we wait for maps in the OSD, because I'm pretty sure it's being overly conservative. Because in general, I think most of the waiting code is waiting for at least as new a map as the sender, whereas we only really need to make sure that the sender is in the same interval that we are. And so the sender should be saying its lower bound on the map change instead of its current map, basically. So I want to go through and audit that and make sure the requirements actually, checks actually make sense. It's kind of a mess. They're all mixed up all over the place, but that can come. Again, I think that can come after.
Well, with the current code, all we have is the map that the sender sent based on, right?
Yeah, but I think it should be tagging all the messages with the newest map.
Yeah, the sender should be. Also the client. Right. Yeah. So for all your pairing messages, that's pretty straightforward. Just switch the epic sent or whatever, query epic, both of them, I think, actually, to be same interval since. Client's trickier, though, because they don't maintain enough state to figure that out.
Yeah, they could, but it doesn't matter that much. The one of the things that the fast dispatch does is it changes the waiting for map stuff so that it blocks it did that before, actually, never mind. Basically only slows down that one client. If it sends something and the OSD doesn't have it, only that client's request stream gets blocked, basically. Everybody else can still continue, so.
Yeah, in practice, I've long worried that snap trimming, quite aside from Nick's problem, which is different, anything we do that causes a map change but isn't important causes an unnecessarily large hiccup in client I/O because clients could get the map before the OSDs do.
Yeah,
it would be nice if that were not true.
Yep. Well, now would be the time to do it. It actually wouldn't be that hard to add a little bit of state in the object or to track the last primary sense or last whatever. In fact, I had a patch that did that for the back off stuff and then dropped it because I didn't need it. So now would be the time to add it. Anyway, I'll put that on my list. it would basically send it's the epic that it needs, that OSD needs to have, and the epic that it has for purposes of, sharing incrementals and stuff.
Well, I mean, the problem is that if you send a new IO on a PG, then you haven't been tracking it over time, right?
Yeah.
And most IOs are new. Another approach would be to, in the OSD map, you would include a conservative same triple sense. So things like snap trim trims or other operations that do change the OSD map don't have to update that number, and every client automatically knows, oh, the current map is marked with conservative same interval sense of 20 epochs ago, so I'll just send that.
Yeah, or we could just move. We can move.
I'm just saying, it depends on which version is the big problem, but if it's just nuisance updates, you can fix that in the monitor.
Yeah, you're right. Okay. We should probably move all the snap trimming out of the OSD map anyway, but there are other nuisance updates also. Okay. Is that it? You know what the client could do is it could just have a time bound, like 5 seconds, and it would keep in memory old OSD maps up to 5 seconds old. And if it's sending a new request and it has older maps, it could just repeat the calculation on those too, so it can calculate a lower bound in just the cases where it is likely to matter.
Yeah,
it's only in the case. Yeah, how expensive it is. Yeah, we can hope that the mapping calculation is fast. But anyway, okay.
Hey Sage, we've got output from Ernesto here from the dump mempools command, and looking over it, we're over 1 gig, but we're not at 6 gigs.
3 gigs of data buffers. That's where most of it is.
There it is. Yep.
Let's see. It's 500 megs of onode and 500 megs of other. So the BlueStar cache is right at 1 gig. So that's actually as it should be.
Yeah.
At metadata at least, but it's got 3 gigs of data. So I bet that there's a buffer reference thing. I remember fixing one of these.
But the same test, the same test with reducing the cache to 100 megs instead of 1 gigabyte has conducted the use of cache.
Yeah. So that there's a whole class of bugs where there's a bunch of code for reference counting buffers in Ceph that can sometimes be too clever for its own good. So what's probably happening is that some object in the BlueStar metadata is referencing like a few bytes out of a larger memory allocation, and that larger memory allocation can't be freed because we're just using a small piece of it. And so it's still effectively bounded by the size of the BlueStar cache, but it's like 10x or something. Which is why you see that showing that reducing the BlueStar cache size frees it. So we just need to figure out which buffer that is and go fix it. I'll see if I can reproduce. I'll put this on my list. I'll see if I can reproduce this and see what's going on. BlueStar EC memory utilization. I guess is that if you were using replication, it wouldn't happen because it's slightly different.
Okay, thanks.
Yep, okay.
Quick question before we finish. Caching. There's sort of been a discussion on the Ceph users about, sort of cache tiering versus Bcache on the OSDs, and just wondering sort of what's sort of the official sort of direction that we think everything's sort of going to be going in.
The per OSD caching is effective and useful and something that we want to support. The plan is to improve the Ceph disk command so it can configure it for you, so that it's not so painful to set up. But that it's still harder to administer. It doesn't have some of the advantages that caching has, but it's still effective and useful and whatever. So it'll be a thing. So the flip side of that is, what is the long-term fate of the cache tiering? And I think that's sort of not going away yet. Maybe someday it'll go away if we have something better, but not until we have something better. I guess it's a short one.
Okay. All right, thanks.
Okay.
Hi, Seth. Is there any progress regarding to the persistent caching in the librRBD side?
The persistent caching librRBD. I'm not sure what the status of that is. The question for Jason. I think there are other things that are being prioritized for Luminous with the multi-site mirroring agent, making that more robust. But I don't know what the timeline is for that. I'm not sure.
Okay.
Yep. It was originally something that the Intel engineers were going to work on, and they aren't. And then Jason was going to do some of it, but he has other stuff. So my guess is that there just isn't a person.
Okay.
Okay.
All right. Well, have a good week, everyone.
Thanks, everyone. See ya.
Talk to you later.